Good morning students, this is your teacher Neela Mehlawat and today we'll continue with the same topic, that is the eye defects. Okay dear students, and I hope you have no queries, you are properly understanding the terms that we have in this chapter, right everyone, and I hope you're enjoying it. So dear students, keep yourself safe also, keep your family safe and complete your studies also, because they're also very important, isn't it? Although we are sitting at home, but we have complete class going on, right everyone? So do focus on your studies. So let's begin with today's topic, right? Now see, earlier we've talked about that we'll be talking about the defects of the human eye, right? Now there are three basic defects. In last video, we've talked about what is myopia, right? I hope you remember. So tell me, what is myopia? Just hurry up everyone. What is the another name of myopia? Myopia is also called as, what do we call it? Nearsightedness, right? Myopia is also called as nearsightedness, right? And what do we call hypermetropia with another name? Tell me the another name. The another name is farsightedness, right? It is farsightedness. Okay, dear students. Now tell me if a person has hypermetropia, what does this means? Hypermetropia means that the person can see far objects clearly. Okay, we should always remember the second name. The second name defines that particular defect. So farsighted means that the person can see far objects clearly. Okay, he can see far object clearly, but he has a problem in seeing the objects which are placed closer. जो उसके पास की चीज़ें हैं वो उसे कम नज़र आती हैं, धुंधली नज़र आती हैं, लेकिन दूर की चीज़ें साफ नज़र आती हैं. And myopia, as I told you, it is called nearsightedness. So पास की चीज़ साफ नज़र आती है, दूर की चीज़ धुंधली नज़र आती है. So I hope you remember this. So we are left with third defect in this series, that is presbyopia. Okay, so today we'll be focusing on presbyopia. So this is the third defect that we'll be talking about today. Now presbyopia actually means, this is also called as old sight. ठीक है, why do we call it as old sight? Because it is generally seen in old people. ठीक है, presbyopia का जो second name है, that is called old sight. And why do we call it as old sight? Because it is generally observed in old people. Clear? So in this, the ability of people to see the nearby objects with age decreases. See, we know we have a lens, like this is a convex lens. Now this lens, the focal length of this lens has to be changed, isn't it? And that focal length is changed by ciliary muscles, isn't it? So your lens is there, its focal length changes, and this change in focal length is done by the ciliary muscles. So we call this as power of accommodation. Okay dear students, what do we call it? The power of accommodation. I hope you remember this. So with age, the power of accommodation decreases. जैसे जैसे हम बूढ़े होते जाते हैं, हमारी जो लेंस की एबिलिटी है अपनी फोकल लेंथ चेंज करने की, वो डिक्रीज होती जाती है. Clear? And thus the person cannot see the nearby objects comfortably. You must have seen your grandparents. They have a problem in reading the newspapers. So they will always ask their grandsons or grandchildren to read the newspaper for them. Isn't it? You must have observed it, yes? Because they have a problem in reading. Clear? Because they cannot see the near objects clearly. So this generally happens in old age. That is why we call it as old sight. Clear? We call it as old sight. Clear everyone? I hope you understood. Now what are the reasons why this particular thing happens? See, with age, as I told you, the ability of the lens, just now I told you that the ability of the lens to change its focal length decreases. And which muscles are involved in the changing the focal length? Yes, it is the ciliary muscles. So with age, the ciliary muscles, they become weak. Okay, with age, ciliary muscles, they become weak, and the flexibility of the lens also decreases. Okay, the flexibility of the lens also decreases. What do you mean by the flexibility? Flexibility means the ability of the eye lens to adjust itself. Okay, the ability of eye lens to adjust itself also decreases. So there are basically two reasons. One is the weakening of the ciliary muscles. Our ciliary muscles, they become weak. And secondly, the flexibility of the lens decreases. Diminishing means decrease. Okay, so flexibility of the lens decreases. Now sometimes you must have observed in old people that neither they can see nearby object clearly nor they can see far off object clearly. ठीक है, कुछ लोगों में आपने देखा होगा उन्हें पास की चीज़ भी नज़र नहीं आती, उन्हें दूर की चीज़ भी नज़र नहीं आती. So they have both myopia also and hypermetropia also. Clear everyone? They have myopia also and hypermetropia both. So if such a person is there who has myopia also and hypermetropia also, in that case we use bifocal lens. Which lens we use? Bifocal lens. Clear everyone? We bifocal lens. Now what do you mean by the bifocal lens? Let's look at this. This is called Gandhiji's glasses, isn't it? So they start wearing this kind of glasses. Now what is special about this glass? Just understand this. What is special in this? Now this this glass, this basically, these ये जो चश्मे हैं इनमें दो चीज़ें हैं. There are two things, there are two lenses in that. The upper portion has concave lens and this lower portion has convex lens. Now tell me, you must tell me in which case we use concave lens. If we have which defect is corrected by using concave lens? Tell me, hurry up. Tell me everyone. Yes, very good. Yes, you're right. In case of myopia, we use concave lens, right? And in case of hypermetropia, we use convex lens. So basically, if a person has both of them, we will use a combination of these two lenses, isn't it? The upper portion will be concave and the lower portion will be convex. And such a glasses or such a lens is called bifocal lens. Bi means two. Okay, bi means two. So this lens will also have its own focal length. This lens also will have its own focal length. So we have two focal lengths, isn't it? Every lens has its different focal length. So the person will be using glasses which has two lenses fitted into it. Okay, and such a lens will be called bifocal lens. Such a lens is called bifocal lens. Okay, dear students, let's go further. Now these, I hope you are clear with the three defects. What is the first one? Myopia. Second is hypermetropia and third is presbyopia. Okay, clear? Now there are certain formulas which we'll be using in the numericals. Now this first formula will be used if a person has myopia. Okay, in that case, the F means the focal length. I hope you remember. So small f means the focal length. The focal length is equal to minus x. Now what is x? X means the distance of the far point. X means the distance of the far point. See, in case of myopia, the nearby object, okay, myopia is also called a nearsightedness. So we do not have any problem in seeing the near objects. We always have a problem seeing the far objects. Okay, clear? So whatever the distance that we can see up to, that is your x. So f will be equal to minus x. यानी जितनी दूर का हमें नज़र आता है, जहाँ तक हम देख पाते हैं, वैसे तो हमारा फार पॉइंट इन्फिनिटी होता है, याद है आपको? सो फार पॉइंट इज़ इन्फिनिटी, बट इन दिस केस जहाँ तक हमें नज़र आता है, जहाँ तक हम देख सकते हैं, दैट डिस्टेंस विल बी कॉल्ड एज एक्स. So your focal length will always be equal to x. Okay, we will use this formula in case of myopia. So remember this formula very clearly. F is equal to minus x. Okay. Second, in case of hypermetropia. In case of hypermetropia, we will use this formula where F will be equal to x dash d upon x dash minus d. Now understand this formula very well. This d is the near point. And what is the value of near point? 25 centimeter. What is the value of near point? 25 centimeter. And this x dash will be the distance up to which the person can see. So this distance is your near point. Because in case of hypermetropia, we have a problem in seeing the nearby objects. तो हमारा पास का कितना डिस्टेंस है जहां हम देख पाते हैं, that is your x dash. Clear? D is your 25 centimeter and x dash will be the distance up to of your near point in case of a defective eye. Clear? So what is the formula in case of myopia? F is equal to minus x. And the formula for hypermetropia? F is equal to x dash d upon x dash minus d. Clear everyone? So you must remember these formulas. Okay. Now we'll use these formulas and we'll solve some numericals. Okay dear? Let's take it the first numerical. A person with myopic eye cannot see objects beyond 1.2 meters distinctly. Okay? Just focus on the question. A person with myopic eye cannot see objects beyond 1.2 meter distinctly. What should be the type of corrective lens that is used to restore the proper vision? Now, I hope you have understood the question. Let's see now. What is the defect the person has? बताइए person को कौन सा defect है? Myopia, right? So myopia में कौन सा formula use करते हैं हम? Just remember in your mind. So in this question we'll be using this formula. Second thing, you see the distance given is 1.2 meter. So what is this? Tell me, hurry up. This is your x. So x is 1.2. It is minus 1.2 meter. Okay. X is equal to minus 1.2 meter. Clear everyone? And what is the formula? Formula you tell me. F is equal to minus x. I hope you remember it. F is equal to minus x. You remember? Do you remember everyone? Are you clear with this? So the distance is 1.2 meters. Okay, now put the question in the formula. Put the value in the formula. F will be equal to minus 1.2 meters. Now is there any doubt everyone? Is there any doubt? So F is equal to minus 2 meters. So this will be your answer, isn't it? It's very simple. So x is equal to minus 1.2 meters, F is equal to minus x. So x की value है 1.2, so F is equal to minus 1.2 meters. So this is your answer. Make a block over it. Okay, with your sketch pen, make a block over it. Now what else is asked? What should be the type of corrective lens? Okay, हमें कौन सा lens use करना है यहाँ पे? Just imagine focal length is minus. So which lens has minus focal length? Concave. Very good. So the lens is concave lens. The lens is concave lens. Okay, dear students? Is it clear to everyone? The lens is concave lens. I hope you've understood. Okay. Now let's take up another numerical. This is also I've taken from the NCERT exercise. A person needs a lens of power minus 5.5 diopters. Okay, a person needs a lens of power 5.5 diopters for correcting his distant vision. Okay? And for correcting his near vision, he needs a lens of power 1.5 diopter. what is the focal length of the lens required for correcting distant vision and the near vision. Okay, so first we'll solve the first part. Now think, he has a problem in seeing the far of objects. Means हमें दूर की चीज़ साफ नज़र नहीं आ रही है. इसका मतलब उस पर्सन को क्या है, कौन सा डिफेक्ट है? Myopia. Very good. So we'll first solve the first part. So in this case, the person has myopia. Okay, everyone, the person has myopia. And the power given is, minus 5.5 diopter. Okay, the power given is minus 5.5 diopter. Now tell me, what is the formula of power of lens? Hello everyone, tell me, what is the power of lens? What is its formula? Very good, very good. Yes, so P is equal to 1 upon F, right? Yes, everyone, you are right. The formula is correct, that you are telling me is correct. So P is equal to 1 upon F, and this F should be in meters, right? Now here we have been given power, so we have to calculate F. So we can reverse the formula, right? We will have F is equal to 1 by P. Okay, now let's put up it here. Put the values. F is equal to 1 upon minus 5.5. Okay, I hope you understood. So put the values and tell me, you can calculate and tell me what will be the value. Just hurry up everyone, tell me what is the value. You can remove point, it will become minus 10.55, isn't it? And you can easily calculate. The focal length, the F that will be there, will have in meters. The answer will be in meters. Okay. So you can calculate it further. I am leaving it here. So you will not leave it. You will complete it, right? You divide it. Understood everyone? It will be in points. So minus 10 upon 55, right? Clear? So the lens will have a focal length of dash m. You will calculate the value. Clear? Let's take up the second part, that is a near vision. Okay, near vision की power कितनी है? 1.5 diopter. Let's take another sheet. So P is equal to plus 1.5 diopter. Okay, clear? Now again we got to calculate it. So we will have F is equal to 1 upon P. Okay everyone. Now put the values. 1 upon 1.5. Okay. You will have 10 upon 15. Again you can divide and get the values. The value will be in meters. Clear? I hope you understood. I hope the things are clear. So you will divide and then calculate. You will have the focal length. So your focal length is equal to this. Okay, your focal length is equal to the value that you will get, and the unit will be meters. Okay dear? Okay. I have taken another question for you. The far point of myopic person is 80 centimeters. The far point of myopic eye is 80 centimeters in front of the eye. What is the nature and power of the lens required to correct the problem? Again you see which defect is there. Tell me everyone, what is the defect? The defect is myopia. What is the defect? The defect is myopia, right? Now what is the formula? Just understand what is the formula. F is equal to minus X. I hope you remember. Now X is given is, what is the X given here? What is the value of X? The X is minus 80 centimeter, isn't it? The value is minus 80 centimeters. And what we are supposed to calculate? We are supposed to calculate the power. Okay. So this F is minus 80 centimeters. This means your F is equal to minus 80 centimeters. So your F is also equal to minus 80 centimeters. Okay. So we got to calculate the the power. So power is equal to 1 upon F. 100 upon F, because the value is in centimeters. Okay, the value is in centimeters, so we will have 100 upon 80, right? So we can have 2 5s are 10. Okay, so 5 by 4 diopter. Clear everyone? So your power is equal to 5 by 4 diopter. Now one more thing that they have asked, what is the nature of the problem? Now see, your focal length is positive or it is negative. Sorry, it is minus here. So we got to put minus everywhere. So the focal length is in minus. Power is in minus, right? Because focal length is negative. So power is also negative. So we will have concave lens, isn't it? We will have concave lens. Which lens we will use? Concave lens. So it is asked, what is the nature of the lens? So nature of the lens is concave lens, right? Concave lens we will be using, and it will have the power. It will have the power minus 5 by 4 diopter. Okay, everyone? Let's have one more question for you. This question is in homework. Okay, you complete this question. I hope you understood. Okay, let's do one thing. I am giving you the hints, then you solve it. Okay. See, in this case, you have hypermetropia. So, defect is hypermetropia. Defect is hypermetropia. Clear? So, what is the formula? Tell me the formula, everyone. So, F is equal to X dash D upon X dash minus D. Very good. 25 centimeter. D की वैल्यू कितनी गिवन है? 25 centimeter.